My name is Russ Jaffe. I'm a physician and biochemist, certified clinical nutritionist, and fellow of the National Academy for Clinical Biochemistry, overseas fellow of the Royal Society of Medicine, and I maintain a fellow status in the American Society for Clinical Pathology, American College of Nutrition, American College of Allergy, Asthma and Immunology, and the American Medical Laboratory Immunologist. I'm a fellow of the Health Studies Collegium and director and founder of both PERQUE and ELISA Act Biotechnologies. Well, with that background, there is an ever-increasing amount of information and books and articles about metabolic syndrome and prediabetes and diabetes and weight management and all these issues, and tonight we will address them, but from the physiology first perspective. First, let's look at the concept. The concept is metabolic syndrome, also known as Syndrome X. We will want to look at the causes, but more typically people deal with the consequences, the results, and they try to manage those dysfunctions as best they can. Now, Syndrome X, or metabolic syndrome, includes disposition to hypertension, obesity, hardening of the arteries, atherosclerosis, dyslipidemia, particularly high blood triglycerides and low HDL, and insulin, sugar, energy dysregulation known as diabetes. But at PERQUE Integrated Health, we really are interested in causes more than the downstream symptomatic consequences, and we find great opportunity to manage the underlying issues of Syndrome X and metabolic syndrome when one fully understands and appreciates them. So there is a constellation, a group of different symptomatic expressions, and so when you find someone with unexplained high blood pressure, or you find someone with unexplained blood sugar changes, or high triglycerides, or signs of heart or vascular problems, or management issues, think about Syndrome X, and then think about its cause after tonight's webinar. We are rethinking inflammation and understanding it at a more fundamental level, and inflammation is a component, an amplifier, an aspect of almost all chronic, persisting, and degenerative diseases, all autoimmune diseases. And if we look here, we see in the upper right cardiovascular diseases, and then to the right of that Alzheimer's, senility, and then further around diabetes, particularly type 2, adult onset or insulin resistance diabetes, arthritis, autoimmune diseases, neurological diseases, lung and pulmonary diseases, and even cancers. So inflammation has been recognized at the heart of all of these diverse medical problems, and we have rethought inflammation from its underlying causes, from its fundamentals, and it is really cumulative repair deficit. Inflammation, I was taught, was something to be fought and suppressed. Repair deficit is something to be appreciated and corrected. Inflammation, I was taught, was a fire to be quenched and fought. Repair deficit is an opportunity to get the good stuff in and the bad stuff out so the body can go back to doing the repair it is designed to do. Now, repair deficit is inflammation. Inflammation is cumulative repair deficit. And this slide that I borrowed from BioCarta shows the inflammatory response starting from the bottom of the slide. Blood vessels are involved, endothelial cells, fibroblasts, those first responder cells, and macrophages just a bit above that on the figure. And you see in various shades of green T-class lymphocytes and other lymphocyte products. You see other dendritic kinds of cells, including eosinophils and macrophages and mast cells, and antibody factories like B cells and plasma cells. They're all involved with repair, and when repair is in deficit, they send out messages to stimulate repair, and those messages, those cytokine communication molecules derived from essential fatty acids, help tip the balance either towards repair, if we have omega-3 fatty acids enriched in our cells, or tip the scale towards repair deficit, towards deferred repair, towards what we call inflammation, if omega-6 fatty acids are our principal essential fatty acids. So the dominance of omega-6 fatty acids feeds into, amplifies, and may even have a component of cause to the repair deficit inflammatory processes that are so common. And managing those through the interleukin-cytokine communication molecules involves shifting and changing people's oil so that they have more enrichment in omega-3 fatty acids and active omega-3 fatty acids like EPA-DHA, such as PERQUE EPA-DHA guard, and therefore are able to stimulate repair when it is needed and where it is needed. Now let's look a bit at diabetes. Diabetes is a problem with energy from sugar because the modulator insulin is not working properly. I was taught there were two kinds of diabetes. Perhaps you've heard of type 1 and type 2. Type 1 is insulin dependent, what we used to call childhood diabetes until a number of adults began to acquire type 1 autoimmune destruction of pancreatic islet cells that produce insulin. And in that situation, one usually requires insulin for a lifetime, although the efficiency of utilization and the effectiveness of insulin is under epigenetic or lifestyle control. Type 2, or non-insulin dependent so-called adult onset diabetes, is a resistance to insulin function. It is either receptor not receiving the insulin message properly, or the insulin molecule itself being altered by environmental chemicals that bind to the insulin, alter its shape, and induce anti-insulin antibodies, which are very common in type 2 diabetes, and alter the effectiveness of the insulin even though it's present. Or that the receptor itself has been altered so that the insulin cannot fit as the key into the lock of the insulin receptor. Now there are two new types of diabetes, type 1.5, which has characteristics of both but an incomplete expression, and type 3, where you have full type 1 and full type 2 in the same person. So there are now perhaps 4 types of diabetes, all that have in common a starvation inside the cell for energy from sugar, with generally excess sugar outside the cell, a famine inside the cell where there's feast outside, and the problem is the sugar can't get through the gate or through the cell membrane because either the insulin receptor or the insulin itself is not working properly. Now the causes of insulin resistance are numerous. They include genetics, although that's a small minority, as we'll see shortly. Fetal malnutrition, so if the mom has maternal nutritional deficits or distress, that can be transmitted to the baby, to the fetus. And Barker and Hales in 1992 first called attention to the link between maternal malnutrition, fetal malnutrition, and insulin resistance and the development of type 2 diabetes. Then there's mitochondrial dysfunction, first identified and reported in 2006, where the battery of the cell is reduced in its ability to produce energy, and the consequence is that the cell shifts to survival mode rather than elective protective mode. And then there's the influence of modulating environmental chemicals, the so-called persisting organic pollutants or POPs. And the impact of these environmental chemicals is something that we have a special interest in and will be describing in just a few minutes in terms of their relation to the problem. Now, in the Journal of Clinical Investigation in 2006, there was an interesting article that showed there are 2 sources for the problem that we call insulin resistance. The first has genetic components. That's adiponectin gene polymorphism. And on the other side, on the right side, you see lifestyle changes, high-fat diet, sedentary lifestyle, nutritional deprivations, acidosis, lack of antioxidants. We would add a number to that list. But you see there are 2 parts, genetic factor and lifestyle, and they look about equal size in this figure, but if we weighted them based on their impact on the risk of insulin resistance, the genetic factor would be 8%, the lifestyle changes would be 92%. So most would be on the right, and there is some influence of genetics, especially when the genes are oxidized or damaged by oxidative stress, indicating antioxidant deficits, or they are rearranged by metabolic acidosis and mineral deficits. In both cases, the epigenetic lifestyle changes and the genetic changes lead to a lessening, a reduction in adiponectin. When adiponectin is not adequate, then insulin is less effective, and you lead to T2D or type 2 diabetes with hyperlipidemia, particularly hypertriglyceridemia, and elevations in blood pressure, high blood pressure, known as metabolic syndrome, the precursor to full diabetes and atherosclerosis. Now, mitochondrial dysfunction is associated with the lifestyle changes, that is an epigenetic influence of choices we make on, and their impact on the battery of the cell. And mitotoxins can influence the genes both in the mitochondria and in the whole cell, and these mitotoxins, or persisting organic pollutants that get to the gene level, can disrupt genetic expressions on an acquired basis. Now let's look at an interesting review from the New York Academy of Sciences on the influence of maternal malnutrition. Maternal malnutrition leads to fetal malnutrition with an increase in free radicals because of antioxidant deficits, an increase in acids because of a lack of buffering minerals, and an increase in distress hormones rather than eustress hormones. Amplifying factors include low taurine levels, low methyl donors, including folates and others, such as we have in PERQUE Vessel Health Guard, nucleotide depletion, often from oxidation and antioxidant deficit because PERQUE Potent C Guard antioxidant hasn't been used adequately, increased oxidative stress that can be countered by antioxidants such as PERQUE Potent C Guard, PERQUE Liviguard, PERQUE Repair Guard, and many others of the PERQUE products that fill out the team and fill out the full range of antioxidants that are needed in different places in the body or different components of the cell at different times. And then what's called genomic survival imprinting. If there is a certain kind of maternal distress and malnutrition that can imprint the fetus in its development, and then the baby is primed for either a low energy state, which leads to neurohormone distress, or for the disposition to low energy states that includes amplified sedentary lifestyle and risk of the oxidation problems that we just discussed. So this all leads to poor initial condition of mitochondrial function. The environment, particularly westernized lifestyle, the approach that we take to lessening our activities and lessening our intake of essential nutrients rather than increasing them with longer life, medications and environmental toxins from the environment can all contribute to this. Now we look below that in the pink areas where you see the CNS, the central nervous system, and the ANS, the autonomic nervous system. This influences both cognitive function and sympathetic activity. If cognitive function is involved, then neurodegenerative diseases, particularly prion-based, are amplified. And if sympathetic overactivity is the principal result, then higher blood pressure and resistant essential hypertension can occur. At the level of the muscle and the liver, there's poor insulin response leading to insulin resistance, fat retention and obesity, and the whole host of metabolic syndrome risks, including increased cancer risk. And at the level of the pancreas and its beta cell, less insulin release leads to block to sugar uptake, elevation of blood sugar, reduction of cell sugar, and the classic famine in the presence of feast known as diabetes. So maternal malnutrition can impact the mitochondrial DNA that can lead to poor initial mitochondrial function that can translate into a lifetime of increased risk. And Bruce Blumberg has correctly pointed out that there are persisting organic pollutants known as endocrine disruptors, and these can be referred to as hypertensinogens and obesogens and carcinogens. And while carcinogens is a fairly well-known term, applying this to molecules like endocrine disruptors that also increase the risk of obesity as obesogens and increase the risk of cardiovascular dysregulation, high blood pressure, and hypertensinogens. Mitochondrial toxins amplify and in some cases cause these problems when the mitochondrial toxins are themselves xenobiotics or persisting organic pollutants, also known as POPs. So are there metabogens? Are there things that can influence favorably or unfavorably the mitochondria? And I will leave you to decide that throughout this webinar. Now let's look at these POPs. Let's look at these persisting organic pollutants and metabolic syndrome, even in non-diabetics. An increase in waist circumference, elevated triglycerides, fasting blood sugar, and low HDL cholesterol are reason to think about impaired detoxification, because when persisting organic pollutants are adequately recognized and handled, they're made more water soluble and the body excretes them through urine, through sweat, through stool, and through the breath. Unfortunately, when energy is depleted because sugar insulin responses are not working well or for other reasons of lifestyle, and when exposure to these persisting organic pollutants is increased, there is a risk that the organochlorine pesticides, biocides, and other long persisting PCBs, PBBs, and others will accumulate, will be oxidative stressors that will damage the mitochondrial DNA and the mitochondrial cytochromes, as well as the nuclear DNA and the nuclear ribosomes. So we're learning to our surprise and distress that long-lived molecules like organochlorine pesticides and fungicides and PCBs and DDTs and so forth have long effects as free radical generators, as depleters of antioxidants, and that there are a myriad of consequences, including increases in waist circumference, elevated triglycerides, high fasting sugar, low HDL, and increases in blood pressure as a consequence. And there are particular molecules that are very difficult for the body to deal with and detoxify, including dioxins, furans, and the like. And when you see this constellation, you want to enhance detoxification along with anything else you do, including, if possible, the use of low-temperature saunas to remove molecules like dioxins and furans through oily sweat. Now, first let's look at the conventional view of insulin resistance, and then we will look at the physiology first view of insulin resistance. The conventional view is that genetics in some undefined way contribute either to obesity or inactivity, that just living a long time itself contributes to insulin resistance, and the results of insulin resistance are myriad, from type 2 diabetes, as you see on the left, to hypertension, to dyslipidemia, to atherosclerosis, and to syndromes like NASH and PCOS. There is actually little evidence to support this. The evidence is much more consistent with what our rethinking of insulin resistance involves, and that is the following. Epigenetics, 92%, and genetics, 8%, make up the influences. So yes, genetics account for about 8% of your risk of diabetes, and the choices you make every day, the habits of daily living, the epigenetics, influence 92%. Now, these epigenetic influences of habits and lifestyles increase the risk of inactivity or of activity by the habits you cultivate. Same it is with obesity. It is not so much genetic, but the choice of what we eat, the amount we eat, when we eat it, and the environment in which we eat it that is influenced by the epigenetics. And it's actually sedentary sitting, more than anything else, sitting in chairs. Being inactive for more than 4 hours a day sitting in chairs increases the rate at which you use up your essential nutrients, and that coincidentally increases the risk of accelerated aging. Now, there's also decelerated aging, which means you have enough of the good stuff and the ability to detoxify the bad stuff, and generally you will be more active in that situation, so there'll be less obesity. So insulin resistance is related to sedentary lifestyle by the choices we make, but it is not primarily determined by aging and obesity, because they are derivative of what we eat, drink, think, and do. And yes, insulin resistance contributes to, and maybe at the cause of, type 2 diabetes, hypertension, or at least essential hypertension, dyslipidemia, much atherosclerosis, and syndromes like Nash and PCOS. But again, I would emphasize that 92% of these influences are under control of the individual because of epigenetics, and the remaining 8% due to their genetic makeup. Now, evolution does seem to favor obesity. We see these 4 objects that archaeologists have unearthed in different parts of the world, and they are thought to represent favorable images of long-lived, wise individuals, and notice there is a tendency towards corpulence. The United States is too big, and the costs are getting out of control. If we just look, as Time magazine did in 2004, we find that the weight of America is increasing, and the consequences are substantial. And if we look just to compare the most with the least obese states, as we see on the right, with obesity in blue and diabetes rates in green, the most obese states have 30.5% of their citizens qualifying as obese and 13.7% of the citizens with diabetes, 22.6% in the least obese states, and 9.9% of those state citizens have diabetes. So there is a relatively fixed relationship between obesity and the subsequent development of diabetes. Diabetes will be about 40% of the rate of obesity in that area. And there are differences between the most and the least obese states, but in all cases, we are weighing more and feeling worse. And let's look at that in a bit more detail. Here we go back to 1994, just 17, 18 years ago, and the age-adjusted percentage of U.S. adults who are obese is seen on the left and diabetic on the right, and you see that in no case is the prevalence above 22% for obesity, nor any case above 7.5% for diabetes. If we go forward to the year 2000, 6 years later, we now find some states with up to 26% of their citizens diabetic and up to 9% with diabetes. If we look at 2006, we see now most of the states are affected, and with more than 26% of the population obese in a substantial fraction, particularly in the South, and with more than 9% obesity, again, predominantly in the South and Southeast. I have seen the flash data for 2010, 2011, and the projection for 2012. The increases are continuing. They are not leveling off. And so we are continuing to gain in weight, but not in wisdom necessarily, and increase the proportion of diabetics in the whole population as a result of that obesity. So let's compare 94 with 2000 and 2009. And for diabetes, the same. Compare 1994 with 2000 with 2009. Just 15 years, you see the shift towards a much higher rate of obesity and diabetes. The product, 92% from lifestyle. The 8% genetic risk was the same in 1994 as in 2000 as in 2009. Now let's look at insulin and how it works and why this is such an important aspect of metabolism and life and style. Insulin is produced by the pancreatic islet cells. Secretion is triggered by a rise in glucose. Insulin then goes to the liver and inhibits glucose production, so that tends to lower blood sugar levels. And insulin also goes to the muscle to enhance sugar uptake, so that the muscle has more energy and the blood sugar level goes down. So insulin is the modulator, and when it binds to a receptor in the cell, it can open up the channels to bring sugar in, and that's what its job is, to take sugar out of the bloodstream, put it into the cell so the cell can make energy from it. Now let's look a little more deeply at the cell. And here we see, interestingly, that insulin lack leads to cell starvation. And by default, cells move to fat as a fuel. On the left, you see what happens when there is not insulin. In the absence of insulin, the receptors are present on the membrane, those you see on the top, but there's no insulin to activate those receptors. And the glucose transporters, and particularly GLUT4, the most important transporter of glucose, is inside the cell in vesicles. Glucose remains inside the cell until insulin comes and activates the receptor. The receptor sends a signal. That signal causes the glucose transport system to fuse in the membrane and facilitate uptake of sugar from the blood into the cell by a process of exocytosis. The GLUT4 transporter activates at the membrane, outer membrane level, and glucose is transported into the cell. So we want some insulin, not too much, but not too little. In the absence of insulin, the receptor that brings the sugar in is inside the cell, so the sugar can't get in. And in the presence of insulin, we have the ability to take up sugar enhanced because the glucose transporter, particularly GLUT4, is brought to the outer membrane. Now there's an interesting connection between adrenal distress and metabolic syndrome. In fact, there's a continuum between chronic distress, this is how we perceive the external stresses. It's not as important what the external stress is. What is important is the effect on us, on our learned adaptation to the stresses of daily living. And insulin resistance, and they go together. So internal distress amplifies, potentiates, and makes more likely insulin resistance. Now, adrenal health has to do with stress hormone balance. And adrenal health includes cortisol, the classic flight or fight hormone, the choice of either fleeing from the stress or fighting the stress. Looking at the data and with our cross-cultural studies, we find that there really are three choices: flight or fight or fortitude. We can choose to flee the stress, or we can choose to fight the stress, or we can choose to be with the stress without resistance. Fortitude itself can be cultivated not particularly at times of stress, but at times when we're at ease. And when we cultivate internal ease through mindfulness practices and through activities that reinforce our forbearance, we find that under stress, we can see opportunity instead of only danger. Now, cortisol as a hormone, as a molecule, is our alert molecule. It slows down our digestion. It suppresses immune defense and repair so that we can keep attentive to whatever the stress outside is. And on the right in this slide, you see a diagram of the kidney with the adrenal sitting on the top. The adrenal has two parts, the medulla in the middle and the cortex on the outside. The medulla is responsible for the neurochemicals like epinephrine and norepinephrine, also known as adrenaline and noradrenaline. And the cortex is responsible for glucocorticoids, like cortisol, and mineralocorticoids, like aldosterone, that have to do with salt balance and blood volume, and sex steroids, like testosterone and estrogens. All of these come from the cortex of the adrenal gland, while the neurochemicals, like epinephrine and norepinephrine, come from the medulla. If we look at the adrenal gland by diagram, and we look at stress hormone balance, we find that the adrenal cortex is responsible, if we go around clockwise, for aldosterone, mineralocorticoid, cortisol, glucocorticoid, and then a variety of anabolic and catabolic hormones, progesterone, testosterone, pregnenolone, estrogens, with DHEA as the mother hormone. DHEA is the source from which the other downstream estrogens and testosterones, the anabolic and catabolic hormones, come. DHEA has been called the feel-good anabolic hormone. It promotes immune health and youthful vitality and is often depleted or deficient in people at risk. So we do recommend measuring the active and free hormones. We recommend measuring the active free cortisol and free DHEA, either in the plasma or in the saliva. And the active hormones, the free cortisol and free DHEA, give you a reasonable measure of those hormones' balance or imbalance. Very often the DHEA is low, and we recommend supplementation to bring DHEA into the upper half of the usual laboratory range which is where healthy people have their DHEA levels. Now, what about the cycle of adrenal distress? If we look at this on the left, you can have stress that stimulates the adrenal glands to produce cortisol, that over time, and especially on repeated stresses, cause adrenal overactivation and eventually adrenal exhaustion, with eventually low cortisol that makes the body less able to respond to stress, so we're less stress resilient. Eustress, the balanced healthy state, is one where the DHEA is up and the cortisol and the DHEA change together in rhythm. Distress is initially characterized by cortisol going up where DHEA can't follow, an excess of cortisol and a deficiency of DHEA, and further persistence of stress causes the cortisol to come down and the DHEA is also down. So you can have exhaustion where both are down, and you can have disposition towards adrenal dysfunction where cortisol is still up but DHEA is down. We want a balance of cortisol and DHEA. When cortisol goes up, DHEA should go up. And when cortisol comes down, DHEA should follow as well. So there should be a rhythm and balance between cortisol and DHEA. That's what we call eustress. And distress occurs when they part company, usually in the beginning stages, cortisol being excessive and DHEA deficient. And then with further adrenal exhaustion, you have a diminution and a lessening and a low cortisol along with the low DHEA. Let's look together at these issues, particularly physical stress such as trauma and pain, infections, poor nutrition, psychological stress, high blood sugar. All of these are associated with increased problems. These are the causes of adrenal resistance and elevated cortisol. And the symptoms of high cortisol include an otherwise unexplained elevation in blood sugar, blood pressure, lack of restorative sleep and insomnia, low thyroid and hypothyroid dispositions, impaired digestion, particularly constipation, and decreased immune function. Now, there's also a relationship between insulin and cortisol. And so when blood sugar goes up, with healthy people taking in whole foods, it does not go above the healthy range. But if we take in sugar without fiber, if we take in sugar beyond what our body needs at that time, the blood sugar can go above the healthy range. Insulin comes out to drive down the blood sugar, often overshooting on the low side, where cortisol comes in to save the day and raise the blood sugar so that the brain can continue to use sugar as its energy source. We recommend fiber to blunt sugar uptake so you stay in the low glycemic range, and the PERQUE family of meals is specifically the lowest glycemic load possible, glycemic load of 10, and provides for very slow blood sugar to come into the body so the blood sugar level barely changes even though you have steady energy, steady moods, steady productivity, and satiety for 5 hours. So an increase in adrenal stress to regulate blood sugar by cortisol leads to adrenal fatigue. Cortisol should be used sparingly, not persistently. And let's look at those differences. On the left, you see healthy blood sugar and insulin balance. On the right, imbalance of blood sugar and insulin. If we look at the healthy left side, when blood sugar rises, shortly thereafter insulin follows, and with the insulin increase, the blood sugar comes down, and the insulin follows. So healthy people, when their blood sugar begins to go up, have a release of insulin to drive the insulin into cells that can use it for energy, and the insulin then is no longer needed as the blood sugar level comes down and restores homeostasis or self-regulation. On the right, we see poor blood sugar and insulin balance. We see blood sugar coming up and insulin coming out. That's the first red and yellow. But the normal response, which is a slow decline, is accelerated in this situation where you have less effective insulin utilization, insulin resistance, if you will. And so insulin is overproduced, trying to drive over that problem initially, and now blood sugar comes down too quickly. And the rate of change of blood sugar is what's important to the brain for perception. The symptoms of hypoglycemia are related to the rate of blood sugar change more often than to absolute low blood sugar levels. So if blood sugar comes down too fast, we can feel that loss of sugar energy. It's called hypoglycemia. And then there's often an overshoot below healthy levels, an overshoot above and back down, and you have a roller coaster blood sugar activity because of impaired uptake of too much blood sugar from the diet, dietary choices being restructured towards simple sugars and away from high fiber, and also the issue of overzealous or overactive insulin that accelerates the blood sugar decline but makes it come down so fast that it often goes below healthy levels, causing the symptoms of hypoglycemia. Here we see a montage of the syndrome of adrenal imbalance. Fatigue, food cravings, and more are characteristic. On the left, you see lack of energy and lack of restorative sleep, maybe insomnia. On the upper right, low serotonin and low levels of blood sugar. On the lower left, what's called brain fog. If the brain does not have glucose, it can't make connections, and many people experience that as brain fog. Digestive issues, depression, weight gain are all part of adrenal imbalance, as they are also parts of metabolic syndrome. And we at PERQUE Integrative Health have solutions for these issues. Now, in terms of goals, once we rethink inflammation as repair deficit, and we think about how to stimulate the immune defense and repair system to overcome the repair deficit, and we begin to recognize that the primary causal factors for diabetes, metabolic syndrome, and adrenal fatigue are mostly manageable, we understand why physiology first is such a refreshing improvement on how to look at these situations. So physiology first to restore host homeostasis via predictive tests, applied functionally and individually, using reference values as your goal, and I'll be talking about the 5 primary causal reference tests and their healthy values in just a moment or two. So the alkaline way, the clinical approach to sustainable health for life, involves restoring, repairing, and defending the body. The alkaline way brings together the wisdom, the information, the inspiration that we at PERQUE Integrative Health have been able to apply and to put to your good use in your personal and professional lives. So what are the physiology first primary causal markers? They are the repair deficit inflammation marker, which is HS-CRP, high sensitivity CRP, and the goal is to have an HS-CRP of less than 0.5. Healthy people have high sensitivity CRPs of less than 0.5, and anything above that suggests repair deficit. Methylation and detoxification. Here we measure homocysteine, and healthy homocysteine levels are less than 6. Levels above 6 are suggestive of impaired methylation and impaired detoxification. A footnote is that some people are so low in cysteine and sulfur amino acids that they have exquisitely low homocysteine levels because of a lack of sulfur in their diet. And if you see a particularly low homocysteine, ask people to increase the high sulfur foods, the 5 thriving detoxifying foods: garlic, onions, ginger, brassica sprouts, or eggs, 1 or more of those, garlic, onions, ginger, brassica sprouts, or eggs, to provide a sulfur pool. And then we have seen people with homocysteine levels that start out at 1, and after replenishing their sulfur pools, they go up to 10, 15, and 20, a more accurate reflection of the methylation detoxification problem. Antioxidant status is important, and this is measurable by oxidized HDL and LDL, which only form when antioxidants are deficient, and oxidized HDL-LDL should be about 0. Adrenal health is important, and either saliva or plasma free DHEA and free cortisol. The active free DHEA and free cortisol are the active molecules and therefore the ones to measure, not the bound inactive hormone, not the metabolites, but the free DHEA, free cortisol in either saliva or plasma to give an index of adrenal health. And then finally, metabolic status, which is mineral net acid excess status, and the first AM urine pH of 6.5 to 7.5 is recommended. So we can look at repair deficit or inflammation, we can look at methylation and detoxification, we can look at antioxidant status, we can look at adrenal hormone health, we can look at metabolic status, and the way we do that is high sensitivity C-reactive protein with the goal of less than 0.5, homocysteine with the goal of less than 6 when you have enough sulfur in your body, oxidized HDL and LDL, which should be undetectable if you have enough antioxidants, saliva, free DHEA, and cortisol at 4 different time points to check the rhythm, or plasma, free DHEA and free cortisol at 4 different time points to check the rhythm, and metabolic status for the first AM urine pH that reflects net acid excess with the healthy goal of 6.5 to 7.5 if you have enough minerals in your diet and in your body.